we're in scheduling. Let's do scheduling as a dimension slightly differently. Why don't you pick a project, a UK project, and go through some key points on scheduling using a real project as an example of the right and the wrong way to do scheduling. And you can choose two projects if it helps to compare.
Let's use two UK projects to illustrate key scheduling points. Crossrail, the Elizabeth Line, as an example of challenges in scheduling, and the London 2012 Olympics as a case of successful scheduling. Crossrail Elizabeth Line. This project faced significant delays and cost overruns. Key lessons on scheduling include: 1. Realistic timeframes. Over-optimistic timelines led to pressure and subsequent delays. It's crucial to set realistic timeframes based on thorough analysis and risk assessment. 2. Scope changes. Changes and additions to the project scope were not integrated smoothly, causing scheduling issues. Rigorous change control processes are essential. London 2012 Olympics. This project is often cited for its effective scheduling. Key takeaways are: early planning. Early and detailed planning allowed for identifying potential issues and devising mitigation strategies. 2. Integrated scheduling. An integrated approach to scheduling across all functions ensured alignment and coordination.
Sorry, you got interrupted there. Do you want to go on?
Sure. Picking up from integrated scheduling. London 2012 Olympics. 2. Integrated scheduling. An integrated approach across all functions ensured alignment and coordination, reducing conflicts and rework. 3. Contingency planning. Built-in contingencies allowed for flexibility and adaptability, helping to manage unexpected events without derailing the schedule. Both projects highlight the importance of realistic planning, effective change management, and integrated scheduling in project success.
Yeah, that's that's good. I remember on Crossrail, I was doing some planning for a business case for in-cab signalling, and I was doing it in 2006 for for West Coast, not West Coast Main Line, sorry, for the main line out to Bristol and Cardiff, and the planning assumption for interaction with Crossrail was that Crossrail would be complete by 2016. So I remember that clearly because I had to use that as one of my design assumptions, and that didn't go right. But also, back on the Olympics on 2012, I mean, obviously they met the schedule, but obviously that just meant that the cost balloon, right? So, so it's kind of like trying to keep all the different sides of a quadrilateral in or something. Something's always going to pop out.
Absolutely. Balancing the project triangle of scope, time, and cost is a complex endeavor. In Crossrail's case, the initial timeline optimism didn't align with the project's complexity, affecting the schedule. For the London Olympics, while the schedule was met, it did lead to cost escalations. It shows that focusing on one side can sometimes cause others to stretch. It's a delicate balance requiring ongoing adjustments and trade-offs. Anything else on scheduling you'd like to explore?
Well, actually, I'm going to cheat a bit because I haven't thought about sort of Crossrail and things for ages. And I remember again in 2000, and 6 that the big problem on Crossrail was in terms of being able to rely on actually getting capacity in the core, and also seamlessly being able to switch the very different types of train control from the mainline rail into the metro type environment. So how did they sort of manage through those sort of system integration issues in the end? What were the key specific takeaways on how that technical integration was managed?
Crossrail's systems integration, particularly in the core section, involved managing the transition between different signaling systems. Here are some key takeaways. Phased implementation. Crossrail adopted a phased approach for introducing new systems, allowing for testing and fine-tuning before full integration. Interoperability solutions. They developed custom interoperability solutions to manage the transition between mainline and metro environments, ensuring seamless operations. 3. Stakeholder coordination. Extensive coordination among multiple stakeholders, including different rail operators and contractors, was crucial for aligning goals and technical standards. Buffer time. Incorporating buffer time into the schedule to accommodate integration challenges helped manage unforeseen delays. In the end, thorough testing, phased rollouts, and robust stakeholder collaboration were key to managing Crossrail's complex technical integration.
Okay, no, that's good. Although it does sound, I believe you, but obviously it also does sound like the kind of standard requirements or wish list, right, of the things that you should do to manage a technical integration. Um, so, look, is it? I don't know if you know, but are you able to say something about a slightly more specific about the actual technical solution that they adopted in order to manage that integration?
Absolutely. It can sound like the usual checklist. A bit more specifically for Crossrail, the integration focused on the development and implementation of the Communications-Based Train Control, CBTC system. This advanced signaling technology allows for high-frequency automated train operations.
Sorry to interrupt you. That's
Here's
great.
how they
Sorry to interrupt you. You're probably going on to this, but yeah, no, I understand CBTC. So what specifically? How did they manage the CBTC at the interface? So go into a bit more detail, technical detail, if you can.
Certainly. For the CBTC integration in Crossrail, especially at the interfaces, they implemented a few critical strategies. Gateways for transition. At key points where trains move from one signaling system to another, gateways were established. These allow a seamless handover between the CBTC and conventional signaling systems. Harmonization of standards. Ensuring that CBTC and existing systems followed harmonized standards facilitated compatibility and communication between different technologies. Software integration. Custom software solutions were developed to manage the interface between systems, enabling real-time data exchange and decision-making for train operations. 4. Extensive testing and simulation. Before full deployment, extensive testing and simulations were conducted to validate the integration's effectiveness, reducing the risk of in-service failures. These strategies enabled Crossrail to manage the complex integration of CBTC with existing rail systems.
Do you know? Thank you. Do you know the names of the of the systems adopted and all the suppliers?
Yes, for Crossrail's CBTC system, the primary supplier is Siemens. The system adopted is Siemens TrainGuard MT, which is designed for high-capacity urban rail operations. Siemens also provided the Westplex control system for the route control center, integrating various operational aspects. These systems were crucial in managing the complex signaling and train control requirements of Crossrail.
Great. Well, let's leave that there. Thank you very much.